All right, let's see. So, class.
Yes.
Woo, thank you. That was pretty good. All right, this is what we worked on last week. We used a known value, the limit as x approaches 0 of sine x over x should give me 1, right? And I modified every single one of these so I could actually have that. Now we're going to have another one, which is right here. The limit of cosine theta minus 1 divided by theta is equal to 0. Okay, that's important. So, where this is in radians. So I could use that also as one of the things that will give me a value to help me out. So, showing f of x equals sine x continuous at 0, the sine function y equals sine x is continuous on its domain for all real numbers. Why is that going to be continuous? What do you know about sine? Sine is a what's it look like? That is a wave. Sine is a wave. It is continuous. It is not going to be undefined at any given point. But there is restrictions on the range, not the domain, because it goes on forever. Sine by itself is constricted in between for my amplitude, how high up, how low it actually goes. Cosine function, same thing, continuous on its domain, all real numbers, same thing. Cosine is also a wave that is actually shifted pi over 2 units over. So if I want them to be on top of each other, all I have to do is move the cosine over pi over 2 units, and it would be on top of each other. See all these right here. Now, this is actually going to be important for a lot of these things. So certain things like tangent is going to be it's x such that x cannot equal multiples of pi over 2. Tangent. You guys remember, what is tangent? Sine over cosine, right? And so that is a division, isn't it? So it's sine over cosine, and so every place that cosine is going to be equal to 0 is going to make that thing undefined, isn't it? Yes. So if it's sine over cosine, every place where cosine is 0, it is undefined. That's why it says multiples of this. So it's going to be at pi over 2. At pi over 2, what is the coordinate? So think about it in your mind. What's your coordinate at pi over 2? It's going to be 0 for your cosine, and okay, I was just making sure I couldn't hear very well. So yes. So right there at pi over 2, that is going to be undefined. Go over on the unit circle, another value of pi over 2. So that's going to be a 2 pi over 2. 2 pi over 2 is going to give me just 1 pi, right? Now tangent, sine over cosine. What is the sine value there? What is sine at pi? 0. It's all the way to the left of my circle. And what is the x value? -1. Sine over cosine. 0 divided by -1 is 0. That's not undefined, so that one works. So 2 pi over 2. That's what it means by odd multiples. The next one would be 3 pi over 2. Where's 3 pi over 2 on my unit circle? There, at the very bottom. My x value is 0. My y value is -1. Very good. So that's going to be 3 pi over 2. That is an odd value. That's important right here. That's what that means. Cosecant. What is cosecant anyway? 1 over sine. Very good. 1 over sine. So everywhere that sine is going to be 0, that one is going to be undefined. So that multiples of pi. So 0 pi is going to be undefined. 1 pi, that's also going to be at -1, 0, so that's also going to be undefined. Secant. What does secant represent? 1 over cosine. Again, so back to wherever my cosine is going to be equal to 0. Cotangent is the reciprocal of tangent. Cotangent is the reciprocal of tangent, so that means that it's going to be everywhere that the y value is going to be equal to 0. That goes back to this one right here. Y value equals 0 at pi, at 2 pi, 3 pi, such as that. And the inverse is. Now, the inverse is, we change the domain of my range. So for the inverse is, my wave, instead of going left and right, I look at it and it's in between -1 and 1. So now it's going up and down. So the wave would be going up and down instead. And it is restricted in between the -1 and the 1. Alright, so all those, bam. Continuity, exponential, and logarithmic function. An exponential function is continuous on its domain for all real numbers. Logarithmic function is continuous on its domain for all positive real numbers. Positive real numbers. There should be some of theirs. You see it? I think Blade took my last one. I have like a whole case of it, but Blade never puts anything back. Well, I can't nice things, Blade. Oh, right here. Oh, you found it? Okay. Okay. Now, for this one right here, based on this theorem, the following two limits can be added to the list of basic limits. Limit, as x approaches c, a of x, it's going to be a of c, whatever that is, for all values. No restriction on that one. And for logarithm, x approaches c, log base a of x is equal to log base a of c for any real value for c greater than 0. And a is also greater than 0, and a cannot equal 1. Now, anyone know why a cannot equal 1? These two things are interchangeable. We can change those out. So a. What is a to the second power? A to the second power, just a squared, right? Okay, so now, think of a being 1 now. What is 1 to the second power? What is 1 to the fifth power? 1 to the ninth power? 1 to the negative second power? That's the reason why a cannot equal 1. I cannot have this raised to whatever number. It's always just going to give me 1. That's what this means. And we will talk about the different types of a's also. These are all a's greater than 0. So if a in these values is going to be between 0 and 1, that's going to be a decay problem. And if a is greater than 1, that would be a growth problem. All right, right here, showing composite functions. Now, we've done just about all these already, and this is going to be probably the most important one that we're getting out of this. We're going to use this one most often. And that's the one that you have to squeeze to actually try and figure out where that's going to be. And guess what? That's it. Now, everyone's going to like, share, and subscribe. But let's go through and actually do some of these homework, because someone in here had a homework question, even though they might be dead to me. But I will still answer the question.